So I'm here for our pre-observation conference preparation. So first, we're going to start out with the to be remembered information. What standards does this lesson address? So this lesson primarily focuses on standards 4.nf.b.3b and 4.nf.b.4a, which is focused on using tape diagrams to concretely demonstrate the decomposition of fractions into the sum of unit fractions. And then what knowledge and skills are addressed. So the knowledge and skills addressed include three primary concepts. One, students will need to know how to correctly draw a tape diagram to represent the given fraction. And also they need to be able to define the number of sections or groups and shade the appropriate number of parts in order to draw that tape diagram. Two, how to decompose the fraction into its given unit fractions. And then three, write at least two different addition equations that show how to decompose the given fraction into smaller parts with the same denominator. And then what will students be able to do by the end of the lesson? So by the end of the lesson, students will be able to decompose fractions into the sums of unit fractions, explore different equivalent decompositions, and represent them using visual models and equations. So now connecting to prior knowledge. How does this lesson build on prior knowledge? So this lesson builds foundational knowledge from third grade, where students learn that fractions represent parts of a whole, with the numerator representing parts of a whole and a denominator representing the total number of those parts. It also reinforces the concept that multiplication is repeated addition, linking it to division, thereby enhancing their comprehension of fractions as numbers and their manipulation through addition and multiplication. And so how does this lesson connect to students' previous learning? So this lesson connects to my students' previous experience in Module 3, where students decompose numbers into base 10 units to multiply and divide, using place value disk and distributive property to solve problems. In Module 4, students have already built their understanding of measurement, interpreted fractions as division, and apply these concepts to solve problems. And then also previously in Module 5, Lesson 1, students have learned to decompose fractions as the sum of unit fractions using tape diagrams, understanding that when the number of the fractional part increases, the size of each part decreases. Now, students connect these experiences by focusing on decomposing fractions as unit fractions using tape diagrams to represent the fractions as the sum of the unit fractions with the same denominator in different ways. And so now, evidence of students' mastery. So what it is exemplar answer to this exit ticket, which I have attached to our document. And then how and why would students arrive at that answer? So to arrive at this response, students will need to, one, be able to correctly represent the given fraction using a tape diagram. Two, decompose the fraction into smaller equal parts, the sum of the unit fractions. And three, write the decomposition of the fraction in at least two different ways, showing that they understand the concept of equivalence. And then how will you and your students know if they have met the objectives of the lesson? So my students and I will know that they have met the objectives for this lesson if they can, one, correctly represent this problem, and two, explain how their tape diagram represents the given fraction and connect it to decompositions where it's unit and non-unit fractions. Also, now thinking about the depth of processing. So what ideas would you want students to think effortfully about in this lesson? So during this lesson, I want my students to think effortfully about how to decompose fractions into smaller unit and non-unit fractions, and how to represent the sum of the fractions using tape diagrams and number sentences. So why are the effortful thinking targets important for your lesson? They are important to promote genuine understanding. Effortful thinking targets are crucial because they encourage deep engagement with the materials, fostering fostering critical thinking and moving beyond mere memorization. And so, effortful thinking questions. What are the effortful thinking questions you will be asking during the lesson? Why did you choose to ask it during this part of the lesson? What is an exemplar response to these questions? And then how will these questions lead all students to think deeply about the to be remembered information? So for question 1, explain how the number sentence 3 over 4 equals 1 over 4 plus 1 over 4 plus 1 over 4 is the same as 3 over 4 equals 2 over 4 plus 1 over 4, and how are they different? And so then question 2 is, how do you know they are both examples of 5 over 4? Why might someone not notice that they are both examples of 5 over 4? How would you help someone who didn't notice these questions? Not to notice these questions, notice these examples were similar and figure out they are both examples of 5 over 4. So exemplar response is that both number sentences are the same because 1 over 4 plus 1 over 4 plus 1 over 4 and 2 over 4 plus 1 over 4 are equal to 3 over 4. The difference is that 3 over 4 can be broken into parts decomposed in more than one way. And so exemplar response for question number 2, you can decompose 5 over 4 in different ways, but they are all examples of 5 over 4 because they all add up to 5 over 4. Different representations of 5 over 4, such as 1 and 1/4, might not immediately be recognized as equivalent due to their different appearances. To help someone understand that different decompositions of a number are all examples of that number, you can explain that they all add up to the original number. So questions 1 and 2 are designed to focus my students' attention and deepen their conceptual understanding that number sentences are equivalent but can be represented in different ways of expressing the sum. So to start the lesson, students will engage in a turn and talk activity around question 1, aiming to share diverse examples and foster peer-to-peer learning through a structured discussion that ensures all voices are heard. Subsequently, during the mini lesson, students will participate in a whiteboard reflection activity focusing on question 2, aimed at enhancing visualization, engagement, and active participation to facilitate improved understanding and retention of concepts. And so question 3 was, what is the unit? How many units to make 1? And how do you show 1 on your tape diagram? So an exemplar response to question 3 is that a unit fraction is 1 over 4. You take 4 units to make the 1 whole. 1 is represented by the tape diagram divided into 4 equal parts. So question 3 is also inserted as a part of the mini lesson and focus my students' attention on understanding and using tape diagrams to represent mathematical relationships, specifically emphasizing the concept of a unit within the diagram and how to represent the value of 1. The goal is to provide a visual, concrete representation of mathematical relationships, making abstract concepts easier to grasp and fostering problem-solving skills. Question 4 says, did you use the same strategy as blank? How is your strategy similar? How is it different? So exemplar response to question number 4 is yes or no. Our strategies are similar in that we are always adding fractions to get 9 over 10. Our strategies are different in that we use different combinations of the fractions. So question 4 will be part of an independent practice to focus their attention on multiple perspectives, problem solving, and critical thinking. Encourage them to analyze, evaluate, and apply knowledge in various ways. To foster a more inclusive and engaging learning environment, students will participate in a stand-up pair-up activity to brainstorm strategies for promoting diverse perspectives, encouraging active participation, and accommodating varied learning needs. So question number 5 says, do you think the addition equations would work if we had different denominators? Why or why not? So exemplar response to question number 5 would be, no, the addition equation would not work if the fractions had different denominators, because you cannot add parts of different sizes. You need to be sure that all parts represent the same whole, meaning that they have the same denominator before adding them together. Question 5 will be part of the lesson closure to check students' understanding. I want to ensure that they have correctly encoded the to be remembered information, from the lesson and can explain how addition equations won't work directly with different denominators because you're essentially adding parts of different wholes. This effortful thinking question prepares students to add fractions with unlike denominators by converting them to equivalent fractions with a common denominator, using visual models like tape diagram, as they will learn in Module 5, Lesson 20. And so scaffolding, what points in a lesson may students face cognitive overload? Students may experience cognitive overload during the problem set if they do not know how to correctly draw a tape diagram, not divide the tape diagram into equal sections, often because students might not understand that the sum of the parts should equal the whole, or that the ratio between the parts should be consistent, or they are incorrectly labeling parts. Often students might not pay attention to the context of the problem and simply divide a tape diagram into a certain number of parts without understanding what each part represents. So, where in a lesson will you employ differentiated supports and strategies to address the students' varying learning needs? So, we want to know that accurately drawing the tape diagram is essential for students. I'm sorry, I forgot to go back to the top. So essentially, I would want students to know that accurately drawing the tape diagram is essential for students learning fractions, as it provides a visual representation that allows them to understand fractions as part of a whole, making it easier to grasp equivalent fractions, add sum of fractions, and convert between mixed numbers and improper fractions. So that's for the question, what point in a lesson may students face a cognitive overload? So why drawing a tape diagram is important. Now going to the next question of where we would employ differentiated learning and strategies to address the varied learning needs will be during our mini lesson. Our model strategies through a think aloud to address individual needs, allowing students to monitor their own comprehension and problem solving through the guided practice with examples and non-examples. Students can see how I tackle challenges through additional think aloud modeling by seeing my thought processes in action. Additionally, by addressing probable misunderstandings and mistakes in advance, I am able to proactively guide students, assisting them in avoiding typical traps and promoting deeper knowledge by resolving problems before they get entrenched. They will be less likely to make these typical mistakes themselves as a result. And then what scaffolding strategies will you use to support students' understanding? So I will also provide extra processing time with a partner by allowing wait time. So pausing after questions and student responses, providing written instructions, breaking down tasks, and offering additional time for tasks throughout the mini lesson. This will allow all my students, especially those with executive dysfunction challenges, to formulate more thoughtful and detailed responses, encouraging participation, and can lead to a stronger sense of ownership over their learning. By helping all students access relevant information from their pre-existing knowledge base, this approach allows them to effectively integrate new information into their working memory, leading to better retention and ultimately transferring it to long-term memory. And then we have data analysis. So what will be the criteria you will use to sort student work according to the degree of mastery, exceeds, meets, approaching mastery? So our criteria of success includes recognize fractions as part of a whole, along with accurately identifying the numerator and the denominator, correctly represent a fraction as the sum of unit fractions, precisely decompose a fraction into the sum of fractions in the same denominator in more than one way, and then write accurate equations to represent the decomposition of a fraction, and then explain their process of decomposition using visual fraction models. And how will you communicate? Share this criteria with your students. So students are made aware of learning objectives through clear communication via lesson targets, alongside a visual accessible anchor chart outlining the step-by-step problem solving process that they can utilize during a lesson. I will give feedback for students on their papers as I purposefully monitor their independent work during the problem set. Additionally, Ms. Green, our paraprofessional, will provide feedback to her small group as they work together as well.